Section number 16 is entitled Solving Inequalities. I guess I should start off by stating some definitions. That symbol means less than. A is less than B. A is less than B. This symbol is less than or equal to. A is less than or equal to B. The next one says A is greater than B. Greater than, more than. A is more than B. This says A is greater than or equal to. That's the equal to part. A is greater than or equal to. Greater than or equal to. Now, forgetting about the equal sign for a moment. The first one says A, that is the top one says A is less than B. So A is smaller. Notice the arrowhead points to the A. It points to A, the smaller one. A is less than or equal to. A is less than. A is the smaller one. A is smaller than B. Now, the third one says A is bigger than B. A is greater than B. There's only one reason why A is greater than B, and that's because B is smaller than A. The arrow is pointing to the smaller one. A is greater than or equal to B. The arrow always points to the smaller one. If you remember that, but you forget the definitions, which is less than, which is greater than, 7 and 9, the arrowhead points to the smaller one. Let's look at this. This area is small. That area is big. The smaller area goes to the smaller number. 19 and 12. 12 is smaller, so the arrow goes to the 12. Or the open end goes to the 19, the larger one. This says that 19 is greater than 12. You don't even have to remember that it means greater than. It should be kind of obvious that since it's pointing to the small one, 12. Well, forget about what goes in there. You should know that 19 is greater than 12. You should know that 19 is greater than 12. And the arrow points to the smaller one, so now you just remembered, oh yeah, I remember. That's the greater than symbol. And in any one of them, I can sneak in the equal. 3 is greater than or equal to 3. Okay, the arrow always points to the smaller one. So I'm thinking of some numbers, if any. Maybe there's one number, maybe there's no numbers, maybe there's a whole host of numbers. Thinking of a number or numbers that when you add 2 to them, when you add 2, you get greater than or equal to 5. You have $2 in your pocket. How much do you have to raise to have 5 or more? And the answer is 3 or more. If somebody gives you $3 or more, you'll have 5 or more. It'd be better if you see that rather than mechanically taking away 2 from both sides. The answer to this problem is x is greater than or equal to 3. This is an algebraic solution, I guess, or inequality representation of their solution. There are some other ways to denote this. Here is 3. It does say equal. Now, and the arrow goes to the right. That is, its numbers 3 and above. include 3. And there's two options to put at 3. You can put an open circle or a closed circle. You decide which one would include 3. And I'm sure it's going to be that one. Close the circle, or fill in the circle, excuse me. That means include 3 and above. Here's another way of writing down the answer. This is called a number line answer. Another way of writing the answer is interval notation. You need to write the left-hand number of the interval and the right-hand number. The left-hand number is 3. And the right-hand number, well, it goes on forever. Oh yeah, that's infinity. Now, we have two types of brackets. That's one bracket, that's another. This is the third, this is the fourth. These two brackets are open brackets. Don't include, say, 7. From 7 to 9. Don't include the 7. Don't even include the 9. These are closed brackets. You include those numbers. Like, say, from 7 to 9. Include 7 and include 9. But they don't have to both be open or both be closed. You can have, say, from 3 to 9. Include 9, but don't include 3. One last one. You can have include 3 all the way up to, but not including 9. Open bracket means don't include that endpoint. Closed bracket means include the endpoint. Since we're supposed to include 3. Why? Because it says equal to. It's a filled-in circle at 3. Include 3. That's a closed bracket. And at infinity, never ever include infinity or negative infinity. Why? I guess because that number doesn't even exist. Now there's one more notation, and it comes right, you can get it right from the first answer. It's called set builder notation. That bracket means the set of all. The set of all. The set of all x such that. That line means such that x is greater than or equal to 3, and the closed bracket you ignore. That is, you take this answer and all you do is put curly brackets around it, and if the variable is x, you put x and then this line. Put everything in red and you're done. If you did another problem and you learned that x is less than or equal to 11, fine. You put the set of all x such that x is less than 11 or equal to 11. That we already have. You need to include this, 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 and that. The only thing that might change is if the variable was an x. If the variable was an x. If the variable was, say, y, they can never erase that. If the variable was y, if you come to know that y was less than or equal to 11, well then you put y there. That's called set builder notation. I'm going to erase that, and there are 4 different ways of writing down the answer. You will have to find the first one first. Okay. Here's the second way of writing the answer, the third way, and the fourth way is kind of immediate. It comes right from the first way. Let's try some more. So on an exam, you teach him to write all 4 different typers and write the answer in the 4 different ways, or write it in this way or that way. So I'm stuck showing you all the ways. 3x minus 4 is greater than or equal to 5. Treat that symbol like an equal sign. If it were this, equal 5, the first thing you would do would be add 4 to both sides. And you would get 3x is equal to 9. Equals. We'll do the same to both sides under real problem. And you get 3x. But instead of equal, it's just greater than or equal to 9. Divide by 3, divide by 3, the 3's cancel, x is equal to 9/3 is 3. Same thing. Divide by 3, divide by 3, x. Instead of equal, you put greater than or equal to 9/3 is 3. So coincidentally, we get the same answer as before. That's one way to write an answer. I'll do it a different order. Let me go right to the set builder notation. Put this in the middle. X is greater than or equal to 3. The set of all x such that in this statement, and then close the bracket. Nothing to understand. Just put this, and that, and put the answer in the middle. The set of all x such that x is greater than or equal to 3. The third answer is, it can equal 3, so fill it in, and x can be greater than 3. That's to the right of 3. If x is first, and this is a key statement, if x is first, then the arrow goes in the direction of the symbol, namely to the right. Think of that as an arrow. It's going to the right. I drew my line to the right. Interval notation, well, it goes from 3 on forever, up to plus infinity. Never, ever include infinity, or negative infinity. Since we can include 3 because it's filled in, because it says equal, put a closed bracket at 3. Close means include. Okay, that's the second problem. Let's go on to a third problem. Suppose you have 5x takes away 3 is greater than 2x plus 9. But by the way, if you conclude that x is bigger than 7, that does not mean 8 and above. There are numbers other than 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Go into the store. Nothing costs $1 or $2 or $3. And if by chance it really did, well, they're going to add sales tax to that, and it won't be $1 or $2 or $3. It'll be $7.19. Numbers bigger than 7 are not 8 and above. There are many numbers between 7 and 8. 7.1, 7.2, 7.3, 7.4, eventually 7.98, 7.99, 7.100, 7.101, 7.102, 7.998, 7.999, 7.1000, 7.1001. This goes on forever. There are as many numbers, it seems, between 7 and 8 as there are between 1 and 2. And after all, let's call this the first number above 7. We'll call this the second number. We'll call this the third number. We'll call this the fourth number. We'll call this the 98th number, the 99th number, the 100th number, 101st number, 102nd number, and so on, up to the 998th number, 999th number between 7 and 8, the 1000th number between 7 and 8, the 1001st number between 7 and 8. This list can go on forever, and so can this one. There are a lot of numbers above 7 that are not 8 or more. So if you're above 7, since it doesn't have the equal sign, it's an open circle, and you can be more than 7. So there are many numbers between 7 and 8, and 2 and 3, and 5 and 6, and negative 10 and negative 9. There's an awful lot of numbers other than integers. Okay, so we're going to solve this just like we would normally if it said equality, if it had an equal sign there. We're going to bring all the x's to the left side because the left side has more. The left side has 5 and the right side has 2. And I'm going to bring the numbers to the right. That is a negative 3. I'm going to get to the right hand side. Right? And that is equal. I'm doing the same to both sides. We rig this to cancel. 5x minus 2x is 3x. We rig this to cancel. 9 plus 3 is 12. Divide by 3, get x. Divide by 3 on the other side, get 4. X is greater than 4. Doesn't equal, but it's greater than. Okay? So here's one answer. A set builder notation. The set of all x such that. And then write down what's in that box. X is greater than 4. Close it. Another way of writing the answer on number line is, here's 4. It can't equal 4, but it can be bigger than 4. Since x comes first, whichever way the arrow is pointing, you go in that direction. Remember, if x is bigger than 4, that means 4 is smaller. The arrow points to 4. Whether I write the 4 first or not, or last, the arrow points to the 4. You do not go to 4 and go in the direction of the arrow. Only if x is first. First x, then the number. If that's the way it's written, go in the direction of the arrow. Go to this number, 4, and go in the direction of the arrow. Interval notation. It goes from 4 to forever. That is infinity. Don't include infinity ever. Never ever. And in our case, we don't include 4. It doesn't say equal 4. Open bracket. Those are the 4 ways of writing the answer. 1, 2, the third way of writing the answer, and here is yet another way, the 4th way of writing the answer. You need to know at least all but the set builder notation. Some books and or teachers require you to know set builder notation. But it's no big deal. Whatever you say the answer is, you write the set of all x such that, and close the bracket. Okay, how about 3x minus 4 is less than 2x plus 11. I'm going to bring all the x's to the left side because they have more. I don't want to get a negative number of x's. If I'm bringing the x's to the left side, I'm bringing the numbers to the right-hand side. On the left side, I have 1x. On the right side, I have 15. X is less than 15. Here is 15. It does not say equal, so I put an open circle at 15. And I go, since x is first, I go in the direction of the arrow. I shade in the numbers that are less than 15. Set builder notation, we modify our first answer by saying the set of all x such that x is less than 15, and we close the bracket. So those are 2 answers right there. And the interval notation, well, it goes from all the way to the left, which is negative infinity, up to 15. Do not include 15 because it's an open circle. It doesn't say equal. And never, ever include infinity or negative infinity. So there's another answer. You have 7 times 3x minus 2 plus 5. And this is known to be greater than 3 times 5x minus 1 plus 11. So we need to clean up both sides. We have to distribute and then combine like terms. 21x minus 14 plus 5 is greater than 15x's minus 3 plus 11. We just have the 21x's. With the numbers, we have 2. Negative 14 plus 5. You owe somebody $14, you give them $5. You owe them $9. 15x. You owe somebody $3, you owe the bank $3, you give them 11. When you give them 11, think that you give them 3 and you give them 8. The first 3 you give them, you owe them 3. The first 3 you give them brings it to 0. It is, you have $11. You put 3 in one hand and 8 in the other hand. And you go, here's the $3 I owe you, and now I want $8 credit. And I'm depositing $8 into my account. The left side has more x's. So I'm going to bring the numbers to the right-hand side. 15x's, 21x's. 21 is bigger. So I'm bringing x's to the left, numbers to the right. If I take away 15x's, there'll be no more x's on the right side. But I have to do the same to the left. That gives me 6x's is greater than 17. Okay? Now notice that when I make up my number line, the bottom left, I just put one number. I just put one number, in this case 15. If you like, you could put 0. Better put it on the correct side of 15. Don't be putting 0 to the right of 15. Okay. Divide by 6, divide by 6, and we conclude that x is greater than this positive number. You're going to put many numbers on the number line, but you better have an idea where 17 over 6 is. It's between 2 and 3. It's closer to 3. And here's 0. Here's 17 over 6. I wouldn't put any other numbers. I may make a mistake. I can't equal 17 over 6, but I can be greater than it. Those are 2 answers. The third answer, I'll just modify the first one. It's the set of all x such that x is greater than 17 over 16. Close the bracket. Now for interval notation, here's my interval. The left one starts at 17 over 6, and the right end, well, there is no right end. It goes to infinity. Never include infinity. And in our problem, since it says greater than, but not greater than equal, we do not include the 17 over 16. So those are the 4 answers, or the 4 ways. There's only one answer. These are the 4 ways of representing that one single answer. Now, we all know, for example, that 9 is bigger than 7. If I were to multiply both sides, say by 3, if I multiply both sides by 3, I'll get 27 and 21, and 27 is bigger than 21. 21, or 3 times 9, is bigger than 3 times 7. Their sign did not change. Less than. 8 is less than 10. If I multiply both, say, by 4, those numbers by 4, 32 and 40, 32 is smaller than 40. The sign in the middle did not change. But if you take if you multiply by negative numbers, oh, by the way, negative 2 is bigger than negative 5. if I multiply both sides, say, by 6. I multiply both sides by 6. I get negative 12, negative 30. Negative 12 is greater than negative 30. The sign doesn't change, even if they're negative. Even if I start off with negative numbers. If one number is negative and the other one is positive, negative 2 is smaller than positive 10. If I multiply, say, by 3, well, a negative number is smaller than a positive number. Okay, you can multiply by any positive number on both sides, and the inequality symbol will be the same as it was at the very beginning. The inequality symbol never changed. Let me be crystal clear what I mean by that. 3 is less than 10. That's the inequality sign. If I multiply both sides by 6, if I multiply both sides by 6, this is 18 and this is 60. 18 is less than 60. The signs did not change. So what if I have, say, 3 is less than 10, so now I multiply by a negative number. I multiply by a negative number. And you get negative 12 and negative 40. Remember, the arrow should point to the smaller number. Like between 3 and 10, 3 is smaller. So the arrow points to the smaller one. But you know what? Negative 40 is smaller than negative 12. The sign changed. When you multiply by a negative number, the sign changes. Even if both numbers are negative. Negative 5 is bigger than negative 10. If you multiply both numbers, say by negative 2, well, you get 10 and 20. And 10 is smaller than 20. This is 10 and this is 20. The sign changed. If you multiply by a negative number, the sign changes in the middle. If it said less than or equal to, when you change the sign, the equality symbol stays. If you have equality in addition to a greater than or less than, the equality stays. Whether you multiply it by a positive number or a negative number. Top left, if it said 3 is less than or equal to 10, you multiply by some number, the equality symbol stays. When you multiply by a negative number, the greater than switches or the less than switches. Less than switches to greater than. For example, if you have negative 2x is less than negative 6. Now dividing is the same as multiplying. You just multiply by the reciprocal. That is same rule for dividing. If you multiply or divide by a negative number, like negative 2, well here, we wanted to divide by negative 2, because then I get x. You divide by negative 2 and you get 3. But since you divided by or multiply by a negative number, you change the sign of the inequality. If you multiply or divide, in our case we divided, by a negative number, you change the direction of the inequality. The x is greater than 3. It's 3. It does not say equal. And I go to the right. Interval notation, it goes from 3, well, all the way up to infinity. Never ever include infinity. If the original problem said less than or equal, then the equal comes along. And now we include 3. We include 3. Let's try this one. 8x minus 4 is bigger than 10x guess we'll do this problem 2 times. If I bring all the x's to the left side, I'm going to have a negative number of them. 8x minus 2, 10x is negative 2x. And I'll bring the 4 to the other side. The other side is 15. So negative 2x's is greater than 15. Let me write that down again. If I divide or multiply by a negative number, and I'm dividing by a negative number, this symbol changes sign. You get x is less than, and I'm just a positive divided by negative is negative 5 over 2. X is less than negative 5 over 2. Okay, fine. I go to negative 5 over 2. It does not equal, of course. It doesn't say equal. If I put an open circle, and I go to the left, just like the arrow tells me to go to the left. You can only play that game if x is written first. If the negative 5 over 2 was first, you wouldn't go in the direction of the arrow. Interval notation, the left end point is at negative infinity. The right end point, well, that's at negative 5 halves. Do not include negative 5 halves, and never ever include infinity or minus infinity. Now, if you hate this negative x's, that is, if you don't want to multiply or divide by a negative number, you shouldn't get a negative number of x's. Let us bring the x's this time to the right-hand side. Because after all, the right-hand side has more x's. 10x minus 8x's is 2x's. And bring the numbers to the left. If you take away 4 and you take away 11 more, you took away a grand total of 15. And let's face it, if you go to the bank and you take out $4, and then you go back later and you take out $11, 5, 10, 11. How much did you take out? Well, you took out $15. Okay, now you divide by 2, which is a positive number. So I'm not going to change the inequality sign. Divide by 2, you get a negative 15 over 2. Now it's up to you which way you want to do it. Because so far, this way has been better, but here's where you run into difficulty. I don't want to know what the number is bigger than. I want to know what x is bigger than or less than. So you can write x and negative 15 over 2. And if if the arrow is pointing to x, it should always point to x. It points to the smaller one. This says that negative 15 halves is greater than x. There's only one reason why negative 15 halves is bigger than x. And that's because x is smaller than negative 15 halves. Okay, now that I have x first, I write down this number, negative 15 halves. It does not say equal, so it's an open circle. And now that x is first, I go in the direction that the arrow points to, namely the left. Up here, x is not first. Here's x, it came second. Do not go in the direction of the arrow. Do not go to the right. Do not go in the direction of the arrow. Only when x is first can you go in the direction of the arrow. And once again, the left end point tends to negative infinity, and the right end point, well, that's right at 15 halves. Never ever include infinity, and in this case, do not include negative 15 halves. Why? Because it doesn't say it can equal. It doesn't say that x is less than or equal to negative 15 halves. It does not say that. If it did, I'd put a closed bracket at negative 15 over 2. divided by negative 3 is bigger than or equal to 7. Well, to get x alone, you want to multiply or get rid of the division by negative 3. So you multiply by negative 3, and now it cancels and you get x. Multiply the right side by negative 3. You get negative 21. But you multiply by a negative number, so the symbol changes direction. The greater than becomes less than. Instead of pointing to the right, it points to the left. The equality, it just comes along. X is greater than or equal to negative 21. That's one way of writing the answer. Set building notation, the set of all x such that x is less than or equal to negative 21. We want to draw this on a number line. Here's negative 21. It can equal it. I know it can. It says equal right there. And since x is first, the arrow goes to the left. Okay, I go to the left. The left end point is at negative infinity. The right end point is at negative 21. I include negative 21. Do not include infinity ever. Here are your 4 answers. If you multiply or divide by a negative number, you have to change the sign of the inequality. If you have negative 2/3 x is greater than or equal to 10 over 5, well, you want to get rid of the negative 2 and the 3. You're going to multiply by negative 3 over 2. This way the 3's cancel, the 2's cancel, and a negative times a negative is positive, times x is positive x. You do the same to the other side. And you can say, rather smoothly, 5 times 2 is 10, and that kills off the 10 on the top, and you get negative 3. Or you can do it the longer way. You can say this bottom number goes into that top number 2 times, or you can say 5 goes into that bottom number 1 time, and the top number 2 times. And then you can say 2 goes into this top number and this bottom number 1 time and 1 time. And 1 times negative 3 is negative 3, and 1 times 1 is 1. So either way we get negative 3. But we multiply both sides by negative 3/2, which is a negative number. So I change the direction of the inequality. X is less than or equal to negative 3. Here is negative 3. X can equal negative 3. And since x is first, the arrow goes to the left. Fine, I go to the left. The left end point, I'm basically now looking at this number line. The left end point is at negative infinity. The right end point is at negative 3. It can equal negative 3. It never ever can equal negative infinity. One last comment. We're not going to do problems that will give us this answer. If after solving a problem, you come to know that you get this graph. You get that. Well, interval notation. So here is my interval. The left interval is negative 3. The right interval is 7. Right endpoint is 7. It's an open circle at negative 3, so don't include it. It's filled in at 7, so do include it. And on that note, this finishes the section entitled Solving Inequalities. Work on these.